Section 4.3, solving linear equations. Okay, well up to this point we've been dealing with expressions. Now we're going to deal with a linear equation. And I'm sure you all know what an equation is. An equation is two expressions connected by an equal to sign. I'm sure you've seen many, many equations in your life. Now whenever I teach this, I always ask my students, what makes an equation a linear equation? And the answer I always get is, if I graph it, it's a line. And that's sort of true, but not really correct. All right, so linear equation. A linear equation is an equation that can be written in the form mx plus b equals 0, where m and b are numbers. M is not the number 0. The important thing to notice is the variable x. Here's how you know if you have a linear equation. You look at the variables. There might be more than one of them, but you look at them and see that they don't have any powers on them other than 1. They don't have any square roots, any cube roots, or any other roots. And there's no fractions where a variable is in the bottom. That's how you can tell when you have a linear equation. So let me give you some examples here. 2x plus 3 equals 5x minus 9. This is linear. I look at my variables, I see just x. I don't see any powers, I don't see any roots, I don't see any fractions. I'm fine. This one, x squared plus 2x minus 3 equals 0, is clearly not linear. Non-linear. I said not linear. I wrote non-linear. I guess that's okay. Not linear because it has an x squared. If you have an x squared, it's not linear. Those have a different name. Those are called quadratic. We will learn more about quadratic equations near the end of this semester. How about 2/3 x equals 5? Again, this one is fine. This one is linear. It has an x in it, but the x only has a power of 1. No powers, no roots. It does have a fraction. It's okay to have a fraction as long as you do not have a variable in the bottom. So something like 2/3x equals 5, that would be nonlinear because it has an x in the bottom. Can't have that. All right, so that gives you some idea of what's linear and what's not linear and how to recognize it. To solve linear equations, there are two rules that, again, I'm guessing you have seen this before. I'm guessing you're familiar with this. Rule number 1 is you can add or subtract anything to both sides. And rule number 2, you can multiply or divide both sides by anything as long as it is not equal to 0. Okay, there's the two basic rules. In this section, we're going to look at fairly simple linear equations just to get you familiar with using these two rules. And then in section 4.4, we will do more complicated equations. All right, so I'm just going to steal some out of the book here. A minus 5 equals 12. Your goal is to get the a all by itself. Notice that the a is connected with a minus 5. You want to get rid of the minus 5, so you do the opposite. The opposite of subtracting 5 is adding 5. And the rule is, do it to both sides. So a equals 17. There's your answer. How about 2x equals 24? This time, we recognize that the x is connected to something by a multiplication. It's connected by a times 2. The opposite of a times 2 is a divide by 2. So x is 12. All right, so students tell me a lot of times they're confused. They don't know what to do. They don't know when they should add or subtract or when they should multiply or divide. And my answer is simple. Look at the operation you have. Whatever operation you have, you need to do the opposite. All right, so a couple more. Let's say I had 2x minus 3 equals 5. All right, well, I notice I have a couple of things here. I have an x. The x is connected with a multiply by a 2. It's also connected with a minus 3. Now, generally, when we solve equations, we do the two rules in the order that I wrote them in. We add or subtract anything first, and we multiply or divide at the end. So what I see this time is I have a times 2, and I have a minus 3. Typically, we do the adding and subtracting first. So that tells me I need to do a plus 3, and I need to do it on both sides. So 2x equals 8. One more step. The x is connected by a multiply. The opposite of a multiply is a divide. I divide both sides by 2. I get x is 4. All right, the last thing you're going to see here is you are going to see some problems that have some fractions in them. You might have minus 3x over 8 is minus 9/4. Here's my general way of handling equations that have fractions in them. The first thing I do is I look at all my fractions and I find the common denominator. This equation, the fractions, the bottoms are 8 and 4. So the common denominator would be an 8. So I'm going to take both sides of this equation and I'm going to multiply it by that common denominator, but I'm going to think of it as 8 over 1 because I like to have fractions with fractions. All right, so I multiply by the common denominator. This 8 cancels this 8. I just have minus 3x. And over here, this 8 and this 4 reduced to be a 2. I get minus 18. There's my reason for multiplying everything by the common denominator. When I multiply everything by the common denominator, it makes all of the fractions disappear. And students usually tell me that's a really good thing because they don't like fractions very much. Okay, so there's my big suggestion. Get rid of the fractions. Multiply everything by the common denominator. It's then easy. Notice here we're connected by a multiplication. To get rid of a multiplication, we do a divide. And that's a common one where I'll see students do a plus 3 right there. That's not a plus 3. It's not x minus 3, which would tell you to do a plus 3. It's minus 3 times x. When you have a times, you get rid of it with a divide. Answer, x equals 6.